Hello, folks. Scott Guile from Macmillan here. Thank you for joining us today. We have a large number of folks attending this webinar, and I may have some ambient noise. The good news is I am going to go on mute shortly, so you won't have to tolerate that for too long. Before I pass it over to our presenters, just like to review with you what you should be seeing on your screen. In the top right corner, you should see an orange arrow. If you click on that orange arrow, this menu will pop out and you'll see audio options and questions. If you want those to be bigger, to be in the middle of your screen so that you can ask a question easier or change audio options, click on that little square to the far right. To ask questions, simply click on the little chevron or caret or whatever to the left of the questions word, and you will be able to ask us any questions, and we will answer all questions either to the group privately or both. You are muted. We have several hundred folks registered today. There's a lot of interest in this. Last but not least, if for whatever reason you aren't seeing the broadcast on your screen, in your tray at the bottom of your computer, there is a blue flower. When you click on that blue flower, it will minimize and maximize the visual part of the webinar. It does not close it, so that's something that you can do with impunity. Tom Hemmick is, I like to think a bit of a unicorn, really. I mean, he's an accomplished researcher and an accomplished teacher. Usually folks in this business, and I've been in this business for 21 years, are either or, very few are both. I'm not going to read you all his bio. It was in the invite that you got, but it is, needless to say, impressive. Rosen is a graduate student at Stony Brook, and he's been a regular presenter and writer for various channels, including PBS, and he's available to write and talk if anyone in this group would like to speak to Drew afterwards. Without further ado, I am going to pass over to Tom to take it away.
Okie doke. So I presume people are now seeing my screen. I'm delighted that you all could come in today. We had no idea when we first put this together how timely a topic it would be. So the person speaking now is Tom Hemmick, and I'll go for about half the time, and then I'll pass it over to Drew Rosen. So just to go back in the history of how I got involved with online teaching, back in 2013, I was on a provost committee concerning MOOCs, the massively open online course offerings that were very popular at the time. And our committee had a very, what I consider, wise determination. It's written at white down at the bottom, and that is that knowledge should be free, but credits must be paid for. And so therefore, Stony Brook needed to become involved in online education for credits, in addition to any offerings that we would make in the venue of MOOCs. And so a true story, in mid-April of 2014, Associate Provost Eric Radkin walked into my office and said, "Okay, Tom, please have a proposal for an online physics to the provost by May 1st, which was about 2 weeks' time." And I guess maybe I was one of the dumb people that he approached, because I said, I'm okay, but I was going to make it as easy as possible. And so we succeeded in that, and actually we succeeded very well. You can see in these plots here both regular semester enrollment as well as summer enrollment has really skyrocketed in the online version of the course, and it's currently at 400 students in the regular semester and just below 150 in the summer semester. And the results as far as grades are very nice, that the grade distribution from the summer sessions and the grade distributions from the in-person are the same. Online, in-person, it's the same. All is good, but there was always this nagging concern: what about online lab? Because the course offering isn't really complete in physics unless you have both. And so in order to branch this over into labs, we had to have, borrowing from Lemony Snicket, a series of fortunate events. And the first one of these fortunate events is a program set up also by the provost office at Stony Brook called SBOLD, which stands for Stony Brook Online Learning Development Initiative. And what they did was they basically set aside a significant amount of money that could be accessed by faculty members via a competitive bidding process to be used to develop new online offerings. And so perhaps a take-home message to everyone listening that's a faculty member is that you should remind your administration, if you want to have nice things, you have to pay for them. So sometime after SBold had been set out as an initiative, the next fortunate event was that Matt Sellen came by to Stony Brook to give a colloquium. And among the many things he talked about, he mentioned the iOLab device. And having heard about it, I actually elbowed my way into the dinner with the colloquium speaker, and I managed to keep the device he brought with him to Stony Brook in my own hands because I was very fascinated by this. Not as much for in-person equipment as many people use it, but instead for the possibility of developing the laboratory component of the online class that I had already been teaching. And then the third fortunate event is that Nikki Cronin, who had been a PhD student studying with me for a PhD in nuclear physics, decided that her true love was in teaching, and she switched over to the MAT program. So just as she was apologizing that maybe she wasn't going to do a thesis together with me, the tables turned, and she and I together wrote a proposal to SBold to develop an online laboratory course based upon the iOLab device. Nikki became the TA for what was the pilot class that followed after that. She then went on to give multiple invited AAPT talks. She trained the next team of students that would come in and work as the TAs for the undergraduates who would take a class. And when she finished her MAT program, this time a good deed was not punished but rewarded. She was basically offered every high school physics teacher opening on all of Long Island when she applied. So it worked out very well for her, and I think it worked out very well for us as well. So just a brief timeline for what it took to launch this class. Our proposal was in March of 2016, and we received notification of the award in April. The fiscal year in Stony Brook turns over in July, and so for that reason, funds became first available to us in July 2016. And then in fall of 2016 and spring of 2017, we ran the pilot class, which was capped at 30 students for fall 2016, 40 students in spring of 2017, and then following the pilot class, we launched it to all students in summer 2017. So when you look at the graph at the bottom, which shows the pilot class in the first bin, that one was capped at a lower number of students. So in order to understand the growth of the class as a function of time, you need to look at the other curves. The first full year worth of offering, both regular semester and summer, was here. And then now we've leveled off at a little more than 250 students in both the mechanics and the E&M version of the class in the regular semester, and a little bit more than 100 students in the mechanics and E&M version of the class that's offered in the summer. Now, once we did launch, the mechanism by which the class was run was that students would purchase a so-called kit, which included both the iOLab device as well as a collection of parts that were custom designed to go along with the lab write-ups that we had written. So what's it like for the student experience? Currently, Macmillan themselves distributes these lab write-ups. They have ownership of them, and they are distributed as a lab manual via something called vitalsource.com that a number of you may be familiar with. It's basically a mechanism by which multimedia resources of a variety of venues are presented, and it consists of a navigation panel on the left that allows students to jump forward and back within an individual lab to the various parts, as well as from lab to lab. And then the right-hand pane is a lab write-up itself. And even though I'm not going to give a demonstration of an iOLab in action, you can look that up on YouTube. You can look up previous webinars from Macmillan and find a lot of information about how convenient it is to use, how easy the software is, and how fun it is to actually watch data coming in live. I'm going to talk a little bit more about what's the composition of the lab write-ups. They begin with a set of learning objectives, so the students know what it is that they're supposed to be accomplishing in the individual lab. And at the bottom of every introduction, there are a collection of what are referred to here as topical reviews. These are basically a series of worked problems where the problem is not associated with the lab experiment they're about to do, but they're a collection, usually 2 to 3, of solved physics problems using the same physics as the lab they're about to do in case they want to review on what's going on. Now, once they enter into the lab write-up itself, you'll find that many of the instructions, just like having a TA in your room, are given as short video clips. We try to keep each one just down to a couple of minutes because the students shouldn't be allowed to turn off their mind with a really long video, and they'll receive in these the basic instructions for how they perform the lab. So the list of laboratories that are part of this kit, we have 10 labs for the mechanics section of the course. And iOLab was around before we entered the game. And so what I've done is I've called out the experiments that we developed ourselves at Stony Brook. We developed the lab write-ups for all of them, but these are sort of new experiments with the double asterisks. And there's a little bit more information about those in particular in the backup slides. And when the students get their iOLab, it also comes along with this kit of parts that includes a variety of things: breadboard, capacitors, resistors, wire, batteries, battery holders, etc., that allow them to perform 2 semesters worth of laboratory experiments. And in addition to first semester physics, where there are 10 lab write-ups, we also have 11 lab write-ups for the fall semester, everything from electric field plotting down to diffraction. Is offered within our collection of labs. So this is optional. It's not something that's enforced. It's how one delivers this kind of a course. And this is what we chose to do at Stony Brook. The course content is delivered entirely through our learning management system, which in our case is Blackboard. And so what it means is that students, after performing the laboratory experiment, will write up what is sort of a standard lab write-up, and they will hand this in through the SafeAssign, which provides a plagiarism engine. And I won't spend time now talking about all the humorous stories that that generates, but I can share some things later on. Office hours are held online. Up until now, it has been through an SB Connect room, but during the pandemic, Stony Brook has hooked into Zoom, and that is another option. Currently, the TAs are still using SB Connect because our students were already in online labs and they have that as a habit, and there's no reason to change. Once the labs are handed in, it is, quote, hand grading. The laboratory reports themselves appear in a window on the browser of the grader, who's able to go through and basically add comments and questions to the laboratory report embedded within the student's own text, as well as give a grade, any overall comments they want to give, and an examination of the plagiarism. So students access this by finding an assignments folder in the learning management system, where they click in one spot where they hand in a laboratory report, and they have another folder full of quizzes. We give post-lab quizzes that are 20% of the grade, whereas the lab write-up is about 80%. So after we presented this to the pilot class, we took a brief survey. The survey was very encouraging, but I will note that this is a biased sample because this was the 30 students out of about 1,000 that chose to enter a pilot class with a fancy device. It is also rather low statistics. Nonetheless, we asked 5 questions of the form that stated that online or iOLab labs are better with regard to 5 categories: being able to design a measurement, reasoning, being able to discuss your results, manipulate data, record data conveniently, and analyze. And we got pretty good results for these, while they reported that the workload is similar to a regular class and that they would probably choose this again. But really, this was a very lightweight and not robust study. And in order for this to become something that is publishable in PER literature, we didn't have another fortunate event. And that fortunate event was when Drew Rosen joined the class in order to make a study of comparison between online and traditional laboratory experiments. So at this point, I'll let Drew take over. And I will control the slides for you, Drew, if that's okay.
Perfect. Thanks, Tom. Yeah, so I guess I am the next fortunate event to come into Tom's life. So I joined Stony Brook as a PhD student at the Institute for STEM Education, and I think it was like fall 2018 at that point. And I had an interest already in undergraduate physics, lab work in particular. And when I came in, I sort of heard about what was happening here, and I said to myself, "Oh, that's interesting. I've never sort of heard of that sort of thing." And we were sort of interested in learning more about the students' experiences and stuff. And so this has become my PhD thesis. And I guess I've sort of also included my social media stuff if you wanted to, talk to me afterwards about it. So in order to do a study on this, just to give you some more background a bit about Stony Brook, we're a large public university, about 18,000 students. The in-person labs have about 900 students between the on-sequence courses and the off-sequence courses. The online labs have about 250 students. And we also offer this thing called a studio lab, which is capped at 72 students. The study primarily just focused on the first two options because just from a numbers perspective, it's hard to do statistics on a small sample size. And so it's part of why I came in is we need to sort of up the sample size and up the statistical power so we can maybe say something about it, about what's going on. And so the students as well to think about they're primarily engineering and science major students. So you have everything physics majors, biochemistry, as well as the whole slew of engineers. The engineering population got significantly larger, which is part of, I think Tom can speak a bit as to why some of the online labs are implemented. But sort of one of the things we want to look at and think about is why we do lab work. And so the reason is that, physics is an experimental science. And I know Tom sort of talked about his background as a physicist, and he does some work at the particle accelerator a couple miles down the road from Stony Brook. And so he does experiments. My background's in astrophysics. And so you sort of don't really call it experimental astrophysics. It's more observational because you can't really control the way a star, you can't control a star, not quite yet. But if you want to educate people in physics, the experimentation is such a fundamental part of being a physicist and doing physics that every student they need to have that experience. And even if they decide to not become physicists themselves, it's important to develop these scientific habits that come about from doing experimental work. So if you're an engineer, if you're in some other science, or even if you're not a science major, it's still important to think scientifically in the 21st century. I mean, we're in a technological society. Are we talking to over 100 people, I think now, over the internet? I mean, it's so fundamental in who we are as a society. And then, of course, we want to promote scientific inquiry. We want people to get a little bit of a taste of thinking like a physicist. Maybe we can rope in a couple students to become physics majors, but ultimately we want people to get that taste of being a physicist, as well as eventually sort of helping construct knowledge. So lab work can potentially have a link towards what's happening in your lecture course. So potentially students can draw parallels between what's happening in their course and what's happening in their labs. And so, but we sort of realize that there are these sort of problems involved because not everything is perfect. We always are trying to improve on things. Like I sort of spoke about before, Stony Brook is starting to experience some limited resources in the sense that there's a finite amount of space where you can actually put labs. There's a finite amount of rooms. There's a finite amount of equipment. And there's a finite number of people that can teach the labs. And so there needs to be a way to teach this growing student population with the constrained resources that we have. And this also is a mechanism of providing accessibility to a number of our students at Stony Brook are students who work full-time in addition to their schooling. And so perhaps they can't come to an in-person class during the day because they're working a 9-to-5 job. And so they need some other mechanism to be able to take a laboratory course as part of their physics learning. And I guess some circumstances might require alternate teaching methods. I mean, right now we're in the middle of a national pandemic, a worldwide, a global pandemic, where people cannot physically be in the same room with each other within less than 6 feet of each other, let alone handling the same equipment. And so, if anything else, this is maybe a perfect time for having these kinds of alternatives, being able to be able to do lab work from a distance. And so this is where I come in, and this is where I asked about what's going on. So what I want to know is I'm trying to figure out what are the students thinking about when they're doing lab work. So what do they think is the purpose of lab work? And what do they think, how do they value the socialization and the help seeking or teacher support aspects of lab work? Because one of the biggest differences between the two courses is in the distance. In the online labs, you're generally doing it by yourselves in your dorm room, whereas if you're doing an in-person lab, you're working with a lab partner and in a room with other people, other lab groups and the TAs in the room with you. And so I want to focus on these things, and I want to know what are the similarities and differences between these two different learning environments. And is ideally we want to give everybody an equal experience, and so part of giving them the equal experience is understanding what the student experience is like. And so this is sort of the basis of my study. And then based on sort of with those things in mind, we construct what's called a theoretical framework. And what that means is we look at previous literature, and we talk with people like Professor Hemmick, and we talk with other faculty and other researchers, and we think about how do these things connect with each other. And there's this idea that physics learning is related to socialization. I mean, if you want to think for yourself about how you've learned certain things in your life, oftentimes it's done with other people. And so we in the field of science education, we feel like that the socialization aspect is maybe important to learning. And there's a link between what we call these epistemological beliefs or the nature of physics learning and the socialization aspects. And we think about how lab work is promoting these sort of conceptual changes, and they come about through socialization, and this comes about through having arguments with your lab partners or other classmates, and also getting help from your TAs and faculty. And so this is sort of the basis. This is how we think about the things we're looking into going forward. And so we have to design a study. And so rather than just sort of throwing together we created a survey based on, again, we looked at previous results, we looked at previously implemented and research validated surveys, and we put together a survey, and we end up surveying about 1,200 students. Not all of them were usable. I put a question into the survey that sort of was meant to catch people who weren't reading the surveys, and so as it turns out, we ended up with about 1,000 responses, which we were considering valid responses. And so about 200 people didn't read the survey. And that's pretty consistent if you actually look at literature about how often people actually read surveys that they're taking. That's the number, I think it's around like 15% or so is what it ended up being. And that's pretty close to what it is typically. And so we ended up with about 750 students in the in-person environment, about 250 in the online environment. And so, we ran it through some statistical software, and we did some statistical tests to piece together these different factors, this physics learning, this socialization, and this help seeking. And we wanted to see what were the differences between the different environments, and was there any link between these three factors? And so just wanted to sort of present some of the questions that we did. And this, by the way, is currently we've submitted this as a paper, and it's currently under review. The rules, I think, for submitting papers dictate that I can't exactly share the paper online just yet. We're hoping to have it published in the coming months, though again, the pandemic has sort of delayed things. But if you wanted more information, my email address is at the bottom. And so some of the questions we asked involved things like, why are you taking this lab? So like, do you feel like that taking the physics lab is helping your understanding of physics? Do you feel like you're learning physics when you're doing error analysis or doing your data analysis, when you're writing up your lab report, or even just simply do you enjoy doing physics labs? And so all these things sort of come together as part of this sort of construction of a picture in the student's head of what it means to do physics labs. And then so some of the other questions we asked had to do with socialization. So how important is it to have access to the TA in you when you're doing your experiment? And am I more successful when I have other people to work with, or am I okay to work on them on my own? And as well as if something goes wrong, if like a piece of equipment doesn't work or I'm having some trouble with a calculation, what is sort of the process that I go about actually seeking help? Do I go right to the TAs? Do I work with other people? Am I comfortable doing this sort of stuff? And so we ended up with some actually pretty nice results. The first of which is that these epistemological beliefs, these beliefs about the nature of physics lab work and so the purpose of physics lab work, they're the same between the in-person and the online students. And we sort of presenting to you guys as these are distributions of the answers that the students gave, the average score that they gave on an average of 19 questions on a scale of 1 to 5, from strongly disagree to strongly agree. And on the left is the in-person, on the right is, of course, the online students. And you can kind of see that they're both about Gaussian distributions and they're centered about in the same place. And we ran a statistical test. We don't just have to eyeball it, but we did run a statistics test, and it says that that they have equal epistemological beliefs about the two courses. So that's great. I mean, that means that at least in this sense, they're getting an equal experience. And we go to the socialization aspect. And this is so we sort of see a difference here. And this is maybe expected, but we weren't exactly sure what we were going to see. That we see that the in-person students highly value having the socialization aspects with their labs. I mean, you can see that the scores are really pushed towards that 15 mark. That's like 3 questions. They all, a large fraction of the students, about 200, almost 250 students, are saying that 5 out of 5 for all those things. They need to have the socialization. They need to have the TA in the room with them. And whereas with the online students, it's a pretty flat distribution, meaning that they don't necessarily value this as much. It doesn't mean that they're losing anything from it. It just means that this is not something that's necessarily important to them. And we also looked at sort of the help seeking as well. And with the help seeking, we sort of realized that it was a little bit difficult to be able to differentiate the populations. They're about sort of flat. You can maybe see there might be a difference between the in-person and online, but just by doing it by eye usually isn't good enough. And so when we run it through the statistical software, we can't say statistically that there's a difference between equal beliefs. So it means that likely that the students find that they have the sufficient mechanisms to be able to get help, meaning that the in-person students, they're talking to other students and they're asking questions to the TA in the room with them. The online students, they're emailing the TA with their questions rather than sort of having it in the room with them, and perhaps they're talking to each other, meaning that they're somehow connecting with each other through social media or some other things. And so we found it was sort of interesting that there's sort of this difference between the socialization and the epistemological beliefs, basically that we maybe expected there to be some sort of link between the two, but it seems like there might not have been one, in the sense that the online students have maybe selected themselves such that they don't necessarily need that sort of socialization aspect in the same way that the in-person students do. But the thing about this is we want to learn more. And so what we do in order to learn more is we actually talk to the students. Because it turns out if you talk to the students, they'll tell you what they're thinking. And so what we've been doing as we're beginning to interview students and to learn about, really get those nuanced experience, get those really, get to the heart of what they're thinking. And we're wondering if they are connecting with each other through, like, say, social media, or they're just through some sort of happenstance connection, or, well, we don't know that enough from a survey perspective. So this is a continuous study where it's a continuing search for the understanding of the truth. And we're also interested in potential academic factors, so there's like comprehension, lab skills, persistence, and learning. Because one thing we did not measure is we did not measure like how much are students learning in the different environments. That's a little bit trickier to do, and but what we know is that generally, if students are happy and if they have high epistemological beliefs, they usually learn more. But again, we can't say that for certain because that's not something we measured. But usually those two things are linked with one another. So, and that's basically it for this for me. And at this point, I guess both Tom and I are available for any questions you might have.
So thanks for listening, everybody, and we're happy to field your questions.
Thank you so much, guys. I'm actually both Lori Stover, who's the product owner here, and I'm Scott Guile, by the way. I failed to introduce myself at the beginning. I'm the marketing manager for this. We've been trying to get back to people with questions to us, and we may read a couple of those aloud in the QA period, which is now. You may ask any questions of either of these gentlemen that may pertain more to how they did it or what things look like, etc. Go ahead and ask those while we're waiting for questions to come in. I am going to go through and read some of these questions we've gotten more than once, which says to me we should probably read them out loud. The kit seems to be mostly parts for the second semester. Is that correct? That is correct, actually. And on our website at iolabworks.com, we've included to the right-hand side, we have a notification about the kit. We have included a link to a spreadsheet that shows you lab by lab what parts you may need for each of the labs. The kit package is indeed, a couple people have raised this, is indeed $235 if you buy the kit, the ebook, and the iOLab, but the iOLab is available for rental for as little as $42 for 3 months. And the ebook, we're still pricing the exact, the 6-month model for the ebook, but it's gonna be somewhere in the $50 range. So that's obviously a lot more affordable than buying the entire package. We've had a number of adopters also, do some of these and do some inquiry-based stuff on their own to sort of mix and match. But hopefully at the iolabworks.com site, you'll be able to find, again, a resource that shows you what parts you need for which labs and be able to sort of self-source and maybe even avoid some of the labs that seem to need more specialized parts. Let's see.
Hey, Scott, this is Danielle Buckley. I just want to jump in and also clarify that lab manual that you mentioned. We are working on a 6-month option. That is correct, but we already do have the 12-month option out there and available. So users can access and use that 12-month version, and very soon we will have the 6-month one available.
Yeah, that manual is available. It's been available for a while. People are using it. We just, but right now it's a 12-month only price point. The only difference is going to be the price point. Here's a question I believe is for our presenters. Can you describe any differences you see in student success from biological science students taking physics under duress versus engineering students? I think that's an interesting and good question that maybe either of you could jump in on.
Tom, I think you.
Well, I don't know that I would say duress necessarily. Currently at Stony Brook, these offerings go under the course heading of Physics 131 and 132, which is the calculus-based for engineers and hard sciences. And the 121/122 students, which are the biological sciences, pre-med, etc., they are still doing only traditional labs as of today. There will be more information this coming summer, however, because since Stony Brook will be holding all online courses over the summer, what we have done is we have decided to bring the 121/122 bio/pre-med students into the 133/134 course for their summer. And so at that point, we should be able to get that kind of information, and Drew will be hard at it collecting data as always, and can easily make that distinction depending upon which course the students came from. So it's a good question, and we just don't know yet.
Thank you, Tom. So we have a question that I really would like to address if possible, but what I'm going to do is ask it, move to another question, or return to it because it involves showing something. What does a kinematics lab look like using iOLab? Tom, is it possible for you to share your screen and show that to the folks?
Sure, give me just a sec.
I'm going to give you a moment. I'm going to give you
iOLab in. So those of you who can see me, I've got the dongle here. Currently, I have a spring hooked to the force sensor, but I'm not going to use that.
Hold on one second, guys, but before you go on, there is a bar between the slides and the webcam. You can drag that bar. If you want to see what Tom's doing, drag that bar down and he'll be a lot bigger. Continue, sorry.
Okay, so I've plugged in the USB stick, and let me launch the iOLab app. And while that is launching, I'm going to take the spring out because I'm not going to need that. And so for a first thing in a kinematics lab, what I'm going to do is I'm going to, well, first off, you'll see at the top that in bright white letters, it says dongle because it sees the dongle. It doesn't see in the iOLab because I haven't pressed the power button. So when I press the power button, you do see it. And the list of sensors is this set of checkboxes on the left. And the one I'm going to activate right now is called wheel. Wheel is actually this device here that spins. There's no way you could see it from your side, but if you actually look at it sideways, you'll see that it's a series of holes. So it's actually blocking a light sensor just like a classical lab. So one of the things that can be done for this is to simply tell it to record. And I'm now recording. So you see the positions and velocities are all 0. And right now what I'm doing is I'm knocking it back and forth between my hands. And as I do that, and then I'm going to say stop, I can take any of this data and zoom in. And what I'm going to do is I'm going to zoom in first horizontally to the time period when I was doing something. And then I'm going to zoom in vertically on each one of these graphs so that it fills the screen a little bit better. And then what you can see from this data is you can see what was happening as I took this thing and I bounced it back and forth between my hands. And so, for example, right here you see a positive peak in the acceleration. That's because I hit it with one of my hands. I don't know which one, left or right. This one I hit it with the other hand, left or right, etc. Now, an interesting thing is that we know that the area underneath of the acceleration curve ought to be equal to the velocity. So if I go and I choose some data analysis, what I can do is I can drag across this area. And then I'm not certain you guys can see as much on the screen, but what you will see is that every graph has been highlighted over a particular time period, and iOLab doesn't know what you're trying to measure. It just makes a measurement. So when you highlight an area, every single measurement gives you a mean, a sigma on that mean, an area, and a slope, even though not all of these are interesting. So in this case, what I've done is I can look at the area underneath of my acceleration curve, and it says negative 9.4 meter per second cubed. So in fact, if I were to zoom in, I'll zoom in a little bit further on a horizontal axis, I could then say, aha, so during that time period of that acceleration, I can see that my left-hand edge, I can see that my left-hand edge, just hovering the cursor, is a particular velocity. My right-hand edge is a different velocity. And if I subtract those two velocities, then I find that the area under the acceleration curve is equal to the difference in the two velocities. So I've shown an integral relationship. If I zoom out a little bit more, I can select a different region. And then I can say, aha, if during this region I look at the position versus time, I can see that the slope is minus 0.27 because I was moving in the negative direction since the position is going down. And I can see that the average velocity during that time period was also minus 2.7. So that shows how velocity relates to the slope of position. So that's just a quick, simple, just whack the iOLab back and forth between two hands, and then you're able to see both the integral relationships going from acceleration to velocity to position, and the derivatives going from position to velocity to acceleration. And that's a kinematics. You can also play a game saying, oh, look, it was slowing down, because the wheel does have some friction. It's real life. And so if you were to zoom in here, you can actually look at the slope of the velocity curve, which here is 0.31, and you can compare that to the average of the acceleration and play all those kinds of games. So I hope that answers your question about what it looks like in a kinematics lab.
Thank you, Tom. Got another question here. Can it be used as a function generator / oscilloscope?
Yes. So a number of the lab write-ups that we have basically do an oscilloscope-like function, except it's slow. The maximum rate of digitization is 4.8 kilohertz, 4,800 hertz. Therefore, you have to keep your functions, if you want to see a nice sine wave that you can get a good Fourier analysis of, you got to keep those below 1,200 hertz. And so this particular lab over here is the one that measures the speed of sound. And what the students do is they roll up a piece of paper and they take their own earbuds and stick it in one end of the piece of paper. And then they get a ramp generator, which basically has an increasing frequency as a function of time. And they measure the microphone at 4.8 kilohertz. And what you find is that you see soft, loud, soft, loud, soft, loud. And then you're able to go to each spot in here and actually take a quick Fourier transform. So you're able to find the frequency at each one of these maxima when you're in a resonant condition, and then plot this versus the number of the resonance, and then use that to deduce the velocity of sound given the length of the tube. So that is effectively an oscilloscope. There's also an RC lab in which you have an RC time constant, and the RC time constant, in order to make the lab viscerable, is set to somewhere from 1/2 second to 2 seconds, depending upon whether they're putting capacitors in series or parallel. So when it switches to charge up, charge down, students are able to get a real feel for the motion of the voltage on the capacitor as a function of time. So that's again an oscilloscope, not a fast one, but we do an LRC lab in which, once again, the students take their computer and they go to this site that generates a sine wave. And what we do is we have a little adapter that accepts a standard audio jack that allows you to intercept the signal coming out of your computer audio before it goes to your earbuds on a breadboard. And what you do is, R is the earbuds, you put an LC in series, and then as you sweep it, you again digitize the microphone, and you see, in this case, a single resonance. We may have a picture of that. Yeah, that's this one. You see a single resonance. And then you can try this with various combinations of capacitors in series and parallel. So you test out the capacitor in series and parallel relations at the same time that you're showing that omega is 1/√LC. And it all works out to the level of about 1% precision. That's this one is more like 5% precision, because you can't buy 1% inductors. So, but the students are actually asked in the lab write-up to interpret the fact that the line slope is really, really good, but it's not exactly the right value. All the measurements seem to be off by the same percent, and why is that?
Thank you, Tom. We're getting a ton of questions about purchase, and I'd like to just touch on that again, and we'll follow up with that as well. You guys should be seeing my
That'll have-
screen. If you go to iolabworks.com, you will see this. This will allow you to, this lab kit that we're talking about can be purchased as a package from us, but you can use the ebook version of this lab kit without purchasing the physical components, and you can source them yourself. This link will show you how to source lab by lab. So in other words, you don't have to purchase the whole physical kit. As someone earlier pointed out, it's more for the second half than it is for the first half, but this would hopefully be a good resource for people that are self-sourcing and are trying to use the ebook version of Tom's Labs along with the iOLab device, which by the way, can be rented, and you can find out rental terms from this site as well. You do have to click here and then here. And you'll see for various periods, we do have what I believe to be very affordable rental terms. So we do have a lot of other, we're probably not gonna be able to get to all of them, so we might have to get some of you guys offline. Questions that keep coming in. Let me bring these up. Sorry. This is an interesting one. What is the typical learning curve for students using the iOLab device? Is there training provided?
In the case of, well, Drew can probably answer this from survey. I can say what's provided, and that is that on the learning management system, we have a collection of both static documents as well as videos that should help the students get things started. And it never works for every student in the class. So some number of them will wind up writing to me or writing to a TA to get things started initially. And so there is a moment when your class is large enough that some people will need some assistance. In the pilot class, those 30 to 40 students, they didn't need any help at all. They were very techy. But now that it has gone mainstream, with about 250 students, I would say there are probably a dozen that need assistance to get going. But once it's going, everything is smooth.
Yeah, the videos, the students, I mean, I have started interviewing people, so they find the videos to be helpful, to be able to watch Tom, I guess, or one of the other, somebody else going through the process of using the device. The students generally, they do become comfortable with the device over time. Like at first, it's a little bit odd to them because it's atypical. It's not what you typically get when you do like a physics lab. Like some students will think back to their equipment they used in high school or the equipment they used in other classes. But yeah, generally over time, I mean, like they become very comfortable with the equipment and they become very familiar with it, and so it's like anything else, they learn. So it's.
And to be clear, the graphs Tom was showing, that was the device. Those were generated by the device, not by.
Oh yeah, this graph where I'm not sharing maybe, but every one of those graphs with a red line on it. Yeah, I can take the share.
One sec.
Mm-hmm.
Should be your way.
Okie doke. So at this point, you should see my cursor, and this graph is raw data from the iOLab, which is gotten by, in my case, using snipping tool to pull it from the screen. This is an Excel plot where after the student has used a variety of different capacitance values, plotted the expected resonant frequency versus the measured resonant frequency. So this is data. This one is also data. And for Kirchhoff's laws, which actually I really like, it's rare to see an actual Kirchhoff lab. The so-called high gain ADC measures 0 to 1 millivolt in a manner that is floating. Now it can't float too far away from 0 to maintain its accuracy. But basically what we do is we make a Kirchhoff circuit and we put 1 ohm resistors in series with kilo ohm so that we can measure voltage across each resistor so that you can get currents as well as voltages. And so this graph here, which is messier, is somebody actually moving the leads and then waiting, that they can create a nice time period of a constant, moving the leads around, and then another nice time period of a constant, so that they've measured voltage at one point, voltage at another point, current, and then I guess there should only be 3 currents. And then in that case, they're able to compare their expectations. And then here, the blue line here is iOLab data. The graph is Excel. Here, the red is iOLab data. And actually, these 3 peaks down here are within iOLab because iOLab has a fast Fourier transform function. So by clicking in the center of each one of these maxima, you're able to read off the peak frequency. It was actually sweeping the whole time, but the peak frequency can then be plotted versus n to deduce whether this chamber is acting the way it ought to, and then after that, figuring out the speed of sound. So each one of these shows some raw data, screenshot of the iOLab, and some manipulation of what you get from there in Excel to do things like fit a straight line.
Thank you, Tom. And I was referring to the ones before you're posted over. Thank you for clarifying that. The device itself is pretty amazing. And again, the lab kit that Tom has put together is 2 things. It's an eBook, and it is a sort of a bag of physical components that allows you to do all 22 labs that he's put together. A lot of folks are finding they can buy the device and the ebook and self-source just for the labs that they are planning on running. Again, at iolabworks.com, there is a grid, a spreadsheet that allows you to see how to self-source. And we're available afterwards to communicate via email. I know there's a lot here and a lot of sort of options we've thrown out at you. I think there are some other questions that are more for our presenters than these. When Tom was manipulating the data for Kinematics, was that the iOLab software? Yes, it was. Is there a smartphone iOLab? No, there is not right now. We would love to someday, but we're not there yet. I feel like I'm missing, there was some other question. There's a number of questions about stock and delivery for summer. We ask that you please contact us via email and we can talk to you. It's the contingent on enrollments, things like that. The contingent on are you purchasing or renting. Here's one. I'm just going to read the first half of it. It's more for you guys. How do students feel about the cost associated with the online course?
Drew?
I guess that's for me.
You've been in touch with their feelings. I don't know if that's been in the venue of your experience. I have some anecdotes.
I think usually some students are okay with it. Part of it is because it's comparable to like the price of a textbook is usually what I say when I have to explain it to people. And then you get to use it for for 2 semesters, and so that helps. Some students kind of don't like that, but some students also don't like the fact that they have to pay. I mean, there's other stuff with the school, and I'm sure Tom can have plenty of anecdotes about issues with having to pay extra money to the university, but I imagine that's going to be true at most universities. I will say, demographically speaking, our students are able, I think, to afford that type of device, like being able to afford the additional device. I mean, something I've thought about is whether or not there are certain school like underrepresented or significantly like higher needs schools may not want to pass the cost on to the students, and potentially the school can do like a bulk buy. I mean, but and now I'm sort of speaking out of my realm of my sphere of things, but it's yeah, it's
just briefly, anecdotally from my side, since you mentioned it, there are about a dozen that complain viciously. Hopefully I can get a little bit less get a better image. There are about a dozen students who will complain viciously about the cost of anything, and Drew's right. The standard reply is it's about the same as a textbook. One issue that we're working on at Stony Brook is that students do pay a so-called lab fee to the university that is for the purpose of maintaining lab courses they would normally take. And currently there is not a mechanism by which that lab fee can be used to purchase the iOLab. And that's something we've been working on, but we haven't got much progress in allowing that to happen at our university. I don't know how that would work at yours.
And again, we're trying to make rental options to make this more affordable. There is some limitation to what we're able to do. I think anyone that has the device and plays around with it is going to be blown away by how much it actually does. And that's our goal here, to, yes, of course, make it more affordable. If we were able to sell 1 million of these a year, we'd make it a lot more affordable because it would scale. So hopefully maybe someday. Here's another good one. We got about 4 more minutes and we do bump up against the hour, and we do need to end because other people use the system. What specific problems, issues have students reported doing their experiments at home?
The number one issue that has come to me, and Drew should also answer this because he's in contact with them, is a misunderstanding of whether they need to replace the battery. And if I just bring the app up again for a moment and turn on my iOLab, there's a readout here that says that my battery is currently at 3.18 volts because I just replaced it before the webinar. In order to preserve battery life, the iOLab actually shuts down the sensors, which, depending upon which sensor, can draw significantly more current from the battery. What this means is that when a battery is marginal, the iOLab will wake up and communicate, but the moment you hit record, depending upon which sensor, the iOLab will die because of battery. And students, when they experience this, belligerently tell me it's not the battery. And so I have to get through to them that if that number is less than 2.85, replace the battery, which they have to do once or twice during the course of 2 semesters. But getting them to believe me that I'm pretty sure it is the battery has been one issue from my side. Drew, you might want to also handle it.
Yeah, no, the battery lifetime has definitely come up. I know Tom usually does the sort of thing where he takes his device and he throws it against the wall to demonstrate that the device is basically indestructible. Usually, I mean, it's usually
not. Were you
not.
there when that student came by and I whacked it against my thigh?
No, but he.
There was a student who claimed their device had become intermittent. And so I told them I would give them a spare if we could reproduce it. And so I started whacking it against my thigh as hard as I could and smacking it and jiggling the USB stick, waiting for any of the behavior that they had described to happen. And when it didn't, they said, okay, I guess maybe it isn't intermittent.
Yeah, no, we've actually done, there's videos on the site of us dropping it off a desk. We also submerged it in water that day. It's pretty tough. I think this is probably our last question, and it is for you guys. Do you utilize any pre-lab exercises or assignments?
That's for Tom. You're the one.
Not in the online class. It's actually one of the features that I prefer in the online to the in-person. In the in-person class, because the students have their 2-hour block and they better get every measurement before they leave, they have to read the lab manual before they come in. Otherwise, they're in danger of leaving without a complete set of data. So they are given a pre-lab quiz whose express purpose is at least you read the lab manual even if you didn't understand it. In this class, they're given a post-lab quiz on whether they have understood the topical material. I like that because it's not punitive. And also, I like the fact that if a student gets into their analysis and says, oh my gosh, I forgot to measure the mass of my iOLab, well, measure it now, that's fine. it doesn't matter to me whether they get it out of order. And so for that reason, I don't mind if they pick and choose, and as long as they have a complete lab write-up at the end, that's great. And also another important feature is the fact that if students mess up their data or it's incomplete in some manner, they could discover that 2 days later and then retake their measurement. Whereas an in-person lab, if you left the lab room with bad data, you're stuck.
That is,
Thank you, Tom. We do have, sorry, Drew, we're bumping up against time. We do have other adopters, including the inventor of the device that does do a number of pre-lab type of things. So it's fairly flexible in that regard. But what Tom had explained made sense. Drew, do you have something quickly?
Yeah, the sort of the same sort of point that what Tom's point, it did come up in the student interviews that the students do like the ability to retake data. They also have the ability to start doing data collection, start doing an experiment, leave for dinner, come back and finish their experiment, which they also seem to like. And you started talking about Matt Sellon, who's the inventor of the device. I don't feel so bad, tooting his horn. What they do at their school is they do sort of a hybrid model where all the introductory labs use the iOLab device in their in-person labs, and the students do the sort of pre-lab activities at home. So everybody owns their own device and they do the activities at home. And they I think helps them familiarize themselves with the device. I'm sure Matt's would be happy to talk about that. I'm sure the creator.
He's always happy to share with anyone that gets hold of him, frankly. And Matt's is a pretty amazing guy. He's the same guy that same team. He was part of it that invented iClicker, by the way. So this is not the first really cool educational invention from the brain of Matt Sellon and the gentleman at Illinois. We are definitely over time now. Thank you so much, guys. This was a number of wonderful questions. We'll be available offline and we'll be sending the recording to everyone. Have a wonderful rest of the week and weekend.
Thank you.
You too. Bye-bye, everybody. And thank you.